So welcome students. Today we are going to just take the revision part, and as I said, the most important chapter for the syllabus is the number system and Python. So today we are going to discuss about the number system. So this is the chapter number system, and the chapter that I'm referring from the book that I'm referring is the NCERT. Okay, that is the book provided by the NCERT. I guess for Python I have already given the chapter to you. If this is not there in the app, I'm going to upload it just after this particular video. Okay, so let us discuss the number system. So number system, so it basically starts with the ASCII code and the Unicode, but that's really not that important as compared to the convergence. So I'm going to directly come to the conversion part. Okay, so that's the number system, and number system for computers is basically of for the binary. Okay, and okay, decimal, and these are the kind of data that it can handle, but ultimately everything gets converted into binary, as you might be aware of, right? So then hexadecimal and octal, and decimal number system is the number system that we understand and something that we use, and hexadecimal octal is something that is used for the designing purpose. That is in electronics we use this for designing the circuits, and computer understands the binary number system because everything is into 0 and 1. So that is what they have spoke in this particular paragraph. Okay, and then we humans we use the decimal number system, and the base value for the decimal number system is 10. Now the reason it is 10, because there are 10 symbols, that is a 0 to 9. Using these symbols we form a number, isn't it? So it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the next number that follows comes with the combination of 0 and 1, so that will be the combination of 1 and 0. So any decimal number, okay, if you really have this positive number, so it's the same rule that we have, can be converted. Okay, if we have that same number with the base value 10, because decimal number system has 10 symbols, so if you do this calculation, okay, it is going to come down to the same number again, because the decimal value is the base value is 10. Okay, so this is decimal number system which we have been using for, which we normally use, and you are aware of this number system because this is the number system that you've been working with. But we are supposed to understand the computer, and to understand the computer we need to understand the number system of the computer. So I'm not going to go into detail of this. I'm going to come to the language that the computer understands, and that is the binary number system. So what they have said for the binary, I'm going to read this now. Okay, so what they have said for the binary, let me just take a highlighter, and now, okay, so the ICs, that is the integrated circuits, because our computer is an electronic device and it has a lot of circuits, right? So when you open the CPU cabinet, you normally see a motherboard, and the motherboard is kind of a, a circuit, and under that we have the devices that are attached. So ICs, and even the microprocessor is a, microprocessor chip basically. So even that's a kind of a circuit. So ICs in a computer are made up of a large number of transistors which are activated by the electronic signals. So what signals? Low and high. Okay, they receive. So basically low and high, so on or off. So low, that is for the off, and high is for the on. So that is what they said. The on off, see, on high, so that is for on for high, and off for low state of the transistors is represented using the two digits, that is 1 and 0. Okay, so these two digits 1 and 0 form a binary number system. right? So this system is also referred as the base 2. Why base 2? Because there are two symbols. So some examples they have given for the binary number system, and this is how the binary number system looks like for the decimal number system. So for a decimal 0, it is going to be 0. For 1, it is going to be 1, and for 2, it is going to be 1 0. So they, if this would have been a 4-bit, that is a nibble, which is for 4-bit, so this would have been 0010. Okay, so you can ignore that 0. That's the prefix 0. It will not make any difference. So so this is 10. If this is a 4-bit, it would have been 0010. Then 3 is 11, and so on. You are already aware of how we got these numbers. Okay, and then we have the octal number system. Now let us see what they have actually said for the octal number system. Okay, which with increase in the value of a decimal number, the number of bits, that is 0 and 1, in its binary representation also increases. Okay, as I said, it is always very difficult to work with a decimal number system, because it's not really that feasible to design a circuit, because the number of a 0 and 1 actually has, there's a huge streams of 0 and 1 that can form with a decimal number system. In its binary representation also increases. Sometimes a binary number is so large that it becomes difficult to manage. Octal number system was devised for compact representation of binary numbers, right? So we can represent the binaries with the help of, in a compact form, with the help of the octal number system. And even the hexadecimal number systems also does the same thing. So octal number system is also called as the base 8 system, because there are 8 symbols. And so in a way, octal number system is basically decreased the number of symbols for the decimal number system. Decimal number system has 0 to 9, then octal makes 0 to 7, so somewhere it kind of decreases the the symbols. Okay, so this is the 3-bit binary number. You can see octal number system, the decimal value, and a 3-bit binary number system. Why 3-bit out here is because it is going to take 3 bits, okay, max to max 3 bits to represent these symbols. So last is 7, so it will be all 1. And when we say all 1, it means all the bits are occupied. Okay, that is what you need to understand. So when I say 7, and if there are 3 bits, so all the 3 bits are now occupied. So then comes the hexadecimal number systems, are also used for compact representation of the binary number system. It consists of 16 unique symbols and is called the base 16 because there are 16 symbols, that is from 0 to 9, and then followed by A to F. So in hexadecimal system, each alphanumeric digit is represented as a group of 4 binary digit, because of 4 bits. Okay, so 2 raised to 4, that's 16, are sufficient to represent 16, okay, alphanumeric symbols. So these are like, goes from 0 to 15, right? And the last number, you can see all the bits are occupied. So this is a hexadecimal number system, and this is the decimal value, that's a decimal number system. And you can see that when we say a decimal 10, so basically in hexadecimal it is A, that's the A symbol. For 11 it is B, and for 12 it is C, and for 13 D, and for 14 it is E, and for the 15 it makes F. And these are the binary number system, the binary numbers. So applications of hexadecimal number system, basically we have the memory addresses, that is 16-bit or 32-bit, and to access a 16-bit memory address, a programmer has to use a 16-bit binary bits, which is difficult to deal with. To simplify the address representation, so hexadecimal and octal number systems are used. So in a way it helps in designing the circuits, please understand this. Okay, and the currently what we are using is, we are not using 16-bit, we are not using, okay, 32-bit, maybe few people are using it, but now we are actually into 64-bit. Your operating system is a 64-bit, your microprocessors are also 64-bit. Okay, So hexadecimal number system are also called used for describing the colors on the web page. Yes, it is used for come up with the color combinations for a web page. So in a web page designing, and this is not really that relevant, but yes, it is used for web page designing. I mean the color combinations. Then convergence between number system, this is what we are concerned with. So how do we convert a decimal to other number system? So whenever we want to convert a decimal to any other number system, okay, that's very good that they have given for any other number system. So the rule, because the rule remains the same, and what is the rule? The rule is divide the given number by the base value of the number system in which it is to be converted, which means that if I want to convert a decimal into binary, so what I'm going to do, I'm going to divide that decimal number by 2. And if I want to convert a decimal number, if I want to convert a decimal number into say octal, then I have to divide this decimal number by 8, because there are 8 symbols. And if the same decimal number, if I want to convert into a hexadecimal number system, then I have to divide that number by 16. So that's good. Okay, anything, any decimal number, if it has to be converted in any other number system, so it will be divided by the base value of the other number system. Okay, and then what's the rule? This note the remainder part, right? And we're going to keep that note of the remainder part, keep on dividing the quotient by the base value, and keep on taking the note of the remainder part. This is what we do. We keep on dividing the number, any number, if you like, it is 28, and then we keep on dividing it, right, and take the remainder part, isn't it? So write the noted remainder in the reverse order, that means from bottom to up. Okay, that's the approach. So always remember, for your exam point of view, any decimal number system, if it is to be converted in any other number system, basically there will be three, that is the binary number system, the octal, and the hexa. So decimal to binary, divide by 2, decimal to octal, divide by 8, decimal to hexa, divide by 60. Please keep this in your mind. Okay, so binary decimal to binary conversion is what they have shown out here, right? So I wanted to convert this decimal number into binary. So what I need to do, I need to divide this by the base value of the binary, that is 2. As you can see out here, I'm just going to enlarge this so that you can see it carefully. So this is the system. Okay, so that's we have divided 65 by 2, and that is a 232 makes, that comes remainder as 1. That's the remainder part. We are going to take note of it, and then since this is an even number, it is going to come 0, all zeros except the last one. So that makes 216, and that is 0, and 28, that is 0 again, and till here 2, that is 2 ones are 2, that's again 0, and at the last, that remainder part, since it is not divisible, we're going to bring that straight away over here. And then the bottom up approach, isn't it? Bottom up approach, and that's the answer. So the hexadecimal number, that is 65, if we convert that into the binary, this is what we are going to have. Okay, so conversion of a decimal number system into its equivalent uh, binary number, that's the figure that they have shown. And then what they have done is, okay, now if you get a question like this which says 122 and the base value that they have shown is 10, which indicates that this particular number is a decimal number. Okay, and we are going to convert that into a binary number. So the same procedure, one more example they have given, a very nice with very good diagram, right? So I'm going to upload this. If I have not uploaded this particular chapter for the NCRT, from the NCRT, immediately after this class, I'm going to upload this, so you can have this. Okay, and you can study from this also. All the contents are good, even the NCRT book is good, even the previous book that we were referring, even that is good. So you can refer it. And if you're already got the book of the Sumita Arora, even that is a fantastic book that you can go for. Okay, then decimal to octal. So decimal to binary divided by 2, decimal to octal divided by 8. So you can see the same number, we have to divide by 8 and we need to collect the remainder part, and the answer comes out as bottom up approach. Okay, so 1018, and I guess this is pretty easy now. And then decimal to hexa, divide that number by 16, and you can see the same number is been now divided by 16, and this is the answer that we have is 41. So that they have said, okay, I don't know how they had 1 4 out here, so this should be, okay, this is something that is wrong out here, that is 41. Okay, okay, that's the mistake. So then next is, you can see that's 122, again that's a bottom up approach, and it will make 2, that is 7a. Now why 7a is because we divided 16, 122 divided, we divided that by 16, that goes by 7, and the remainder is a 10 out here. So if the remainder is 10, so 10 means what in hexadecimal, that is a, right? And then this is not divisible, so it's 7, so 7a. So if it is remainder is like 10, 11, 12, so you have to take that symbol. Please understand it. Okay. So you're not going to write 10, 7 and 10 out here. You're going to write 7 and A. And then conversion from the other number systems to decimal. Okay. This is a very good approach that this book has kept. Now the reverse way, if you want to do it, what are the steps that we need to follow? Now the step is, write the positional number of each alphanumeric symbol in the given number, get positional value of each symbol by raising its position number to the base value b symbol in the given number. Multiply each digit with the respective positional value to get the decimal value, and add all these decimal values to get the equivalent decimal number. Okay, maybe you haven't got much out of this, but once we do one of the solution, you're going to get these steps. So binary number system, if I want to convert now binary to decimal, so what is the approach I'm going to keep? So let us take an example, that is 1101. So what kind of approach I'm going to keep is, I'm going to write these numbers like 1101. Okay, and then what I need to do is, this is like, the the power 2 basically. Okay, it's going to be 0 1 2 3, so it makes 2 raised to 0, 2 raised to 1, 2 raised to 2, and 2 raised to 3. Okay, and then what I need to do is, okay, that is, you can see, so that is 2 raised to 0, so 1 into 2 raised to 0. Can you see this? Okay, because the base value is 2, so we're going to use that 2 out here. This is the base value that we have used. And then plus, that is 0 into 2 raised to 1 plus 1 into 2 raised to 2, so the power keeps on increasing, and then 1 into 2 raised to 3. So this is anyway 0, this goes off, and the remaining part is, we have to add this number. So this makes 8, this makes 4, this will make 0, and this makes 1, and if we add that, it comes down to 13. So this is how we can convert a, from the binary to decimal. Okay, what we did previous was from decimal to the other number systems, and now from the other number systems back to decimal is what we are understanding. Same approach we're going to keep for our octal number system to decimal. So the base value of octal is 8, so we're going to keep the same approach, that is 7 into base value 8 raised to 0, right, plus 5 into 8 raised to 1, the power keeps on increasing, and then 2 into 8 raised to 2, and we are going to add this number. There's no plus sign, there should be a plus sign. So 128 plus 40 plus 7, that is 175, right? And then hexadecimal, can you guess what we need to do? Same number. Okay, just the base value at the place of 8, it will be only 16, and then if the number is like this is the, hexadecimal, so 5, so it will be 5 into 16 raised to 0 plus a, which stands for 10, which means 10, so 10 into 16 raised to 1, and then plus again that is 3 into 16 raised to 2. So that makes it 768 plus 160 plus 5, that is 933. That's the decimal number. So I hope now it is very much clear how we can convert a decimal to binary or decimal to the other number systems and from the other number systems to the decimal. This should be very much clear because during the exam, once you have your question paper in front of you, it is going to confuse you a lot. Okay, what exactly to be done or which steps to follow, sometimes it gets very confusing. Okay, so then conversion from binary number system to octal, hexa number and vice versa. Now this, you can see this particular conversion is the most easiest way, to convert between the numbers, that is binary to hexa, hexa to binary, binary to octal, octal to hexa, and these conversions are very easy, and that is why this numbers system, that is the hexadecimal number system and octal number system, was formed basically for designing, for programming the circuits. These number systems were formed. Okay, so a binary number system is converted to octal or hexadecimal number system by making group of 3 and 4 bits, isn't it? If it is octal, I am going to make a group of 3. If it is hexa, I am going to make a group of 4. Why? Because octal takes 3 bits representation and the hexadecimal number system takes 4 bits to represent a hexadecimal number. So it's pretty easy. So why 4-bit is binary number system are grouped together to get hexadecimal number system? The same question they have asked, and the answer is the base value of hexadecimal number system is 16. Write the right value 16 in terms of exponent of 2. So that is 2 raised to 4 is 16, which means to represent the 16, from 0 to 15, it is going to occupy all the bits. Okay, and the base value is 16 basically. Okay, and max it is going to take 4 bits, hence 4 digits are sufficient. Okay, hence the 4 digits are sufficient to represent all the 16 hexadecimal symbols, isn't it? Just like what we seen before in the table, and the same goes for the octal number system. And so it's pretty easy. Now if I really want to convert this, that is a binary number system, into octal, I am going to make a group of 3, and please make sure that I make a group that is from the right hand side. So 100, that is, see, that was the first group that they made, 100. The second group is 101, and the third group is 10. So just add a 0 out there, so that makes another group of 3. Okay, and then we have to come, that is 100, that makes it 4. How this makes it 4? Because this, you can easily say this is 1 2, so 2 raised to 0, 2 raised to 1, and 2 raised to 4. So this, no, forget the 0, just take the 1, the bits that are on. Okay, so this is 2 raised to 2, so 1 2, and this is 4. So 2 raised to 0 1, 2 raised to 1 2, and 2 raised to 2, that is 4. So this is 4 and this is 5. So you can see 4 and 1 will make 5, and this is 1 and 2. So the on bit is 1, so that is simply as 2. Okay, and then these are very very simple conversions. Then binary number system to hexadecimal number system, yes, we can convert that. Just make a group of 4. So that's the first group, that is 1100. So that is what, so this one, that one out here, 2, I have told how this works like. Okay, this is 4 and the last is 8. So what number is this? So we just take the on values, that is the 1 values. So 1 1, so this is 8 plus 4, so this is actually 12, right? Same, the group of, again a group of 4, so 1010, and then remaining is 01, so add 2 zeros, prefix it with 2 zeros, that makes it 0001. And you can see that this has, okay, what is into hexadecimal, where is the final conversion? And okay, so this is what this was 12, so it will come down to C, right? 10 is A, B is 11, and C is 12. So that is C, that is 12. This is 1010, so this is 8, and this is 2, so that is 10, so that's A, and this is anyway just 1, so 1 AC 16, right? So all this is pretty simple. Because the conversions are simple. When we talk about a hexadecimal number system to the octal and binary number systems, when there are convergence between these three number systems, it's pretty simple. The moment the decimal number systems comes into the picture, the things becomes a bit complicated. Okay, so this is what we have discussed for today, children. So then what we're going to do is tomorrow we will discuss about the fractional values. Okay, how to work with the fractionals. I'm going to anyway give this the PDF to you. You can also go through it. We have discussed this before also. And then tomorrow one more day we are going to give to the number system, and then day after tomorrow, that is on Friday, we are going to discuss about Python. Okay, so these are the important topics for your upcoming exam. So please, we have to really work hard on this. And also you need to keep on practicing your programming, and that is the reason why I'm taking so many programs one after the other. Yesterday I took some interesting program that was of the convergence, right? The same convergence that what we have learned. So what it means that whatever we are learning in computer, okay, the number systems or anything, right, we can program that. Okay, we can come up with a program which simulates the same thing that what we learn in our daily life. And programming is something not only to simulate, but it is also something to come up with a solution. So there are problems, and there is, when we are into this world, so we are faced, or we are surrounded by problems basically. Okay, and as a computer programmer, you're just not going to be like any other engineer. You are going to be a problem solver. You need to be a problem solver. So there are going to be a lot of problems in which will be surrounding you basically, and you need to come up with a solution. You can also help so many people who are finding something that is very difficult for them. It can be a small shopkeeper who finds it very difficult to handle his daily sales, and as a computer programmer you can help him to come up with a better solution. So computer programming is something that you know is about solving the problems that we face in our daily life. It might be someone who is your at your neighborhood, who has a huge amount of data. The person is not aware of how to handle the data. He needs to filter out something from that data, and as a computer programmer you can help the person just writing few lines of code and just come up with a solution. So computer programmers are like a savior basically, right? So it's a very big and very huge and very nice field to be in, because future is going to be about technology. You and me are connected today because of technology. During this pandemic time also, our studies did not got affected because of technology. Just imagine if there wouldn't have been technology, or the same thing, the same pandemic would have come maybe even maybe 15 years ago. So maybe there would have been a serious problem, because the education would have got affected seriously, because we did not had that internet speed and all that. Even 15 years ago we did not had all that. So this is what is all about, children. So that is why I always take programs, okay, which will guide you that there is a problem, and as a computer programmer you have to provide a solution. Okay, always you have to keep that approach, that you are a problem solver for others. Okay, so that is all about for today, children. Please go ahead, study, and do not study only to get marks. Okay, I want out of. No, yes, it is good to have out of, but more important is about knowledge. Okay, knowledge is very important, and with that knowledge, how you are able to change, you know, things for yourself and for others. That is what is important. So knowledge is important. Okay, so focus on knowledge. So that's it for today. Bye for now.